Today I'm going to make a tightening fixture for the ISO 20 holders on my machine. Welcome to another episode. So the tool holders on my machine are ISO 20 with ER16 collets, and they are supposed to be tightened to a specific torque to get the maximum holding power. And I've run into this in the past with this particular end mill, which is a 3/8 inch end mill, where it has pulled out. So I purchased a torque wrench, and in this episode I'm going to make the tightening fixture that allows me to hold this so it doesn't turn. Now you're going to see that, as Tom Lipton would put it, Mr. Bozo has made a visit to the shop, well, maybe more than one, and I also saw Blondie Hacks this week where she ran into a few issues, so it seems like something is in the air. I definitely had a few issues, a few mistakes I made, things that I shouldn't have made. You know, I have enough experience with the machine now, but I guess I was kind of taking this project not seriously enough, and also perhaps trying to rush it through. I started this project this morning and finishing it in the evening, trying to get the project and the video done all in one day. And for those of you who have not done YouTube videos, it actually takes a lot of work, a lot more work, to make something when you're filming it and then editing it and making sure that there's some flow. Anyway, let me head to the workbench and show you what I'm up to. One of the things I need to solve is how to apply enough torque to these when I tighten them. For smaller drills like this or smaller end mills, it's not much of an issue, but for something like a 3/8 inch diameter end mill, I want to have this torqued down to the correct setting. And it turns out that the correct setting is 22 foot-pounds. Now, what I've been using to tighten this is a wrench that I had to grind down on either side so that it would fit over the flats that are on here. And then I have this tool for tightening this nut here. This tool is about 4 inches long, so that means if I want a target of 22 foot-pounds, it means that at the end of this right here, I have to apply 66 pounds of force, which is quite a bit. So I decided I was going to get a tightening fixture, and I bought this one from China. It says it's an ISO 20 tightening fixture, and I thought, great, you know, I can buy something that wasn't that expensive and I can just start using it, and it's perfect, except it doesn't work with the flats, and basically it's not effective at all because it doesn't keep it from rotating. So I decided to make a fixture. This is the torque wrench that I purchased. One of the problems with using this particular style of holder and having a machine like I have, which is the Haas OM-2A, is that this holder seems to only be made by one company, which is Techniks. I did buy some other holders from China because that's the only other place I could find, but they're not the same. So they're not compatible with the tool changer on my machine. So that meant I ended up getting this torque wrench, and this torque wrench goes up to 22 foot-pounds quite easily. So it shows it in newton meters, which says 10 to 15 newton meters, and I'm not sure how much that is in foot-pounds. Anyway, this will allow me to tighten it exactly to where I want it to be as soon as I make a tightening fixture. So let me take you to the computer and I'll show you what I've designed. The design I came up with is pretty simple. It's based a little bit on the sheet metal one that I showed you in terms of there's 1 inch from here to here and from here to here. And I'm just going to clamp this to the table with some clamps in the beginning when I start getting used to it. At some point I'm going to put some holes in here and then bolt it to some bench to make it easier. One of the things I did is I started by modeling the ISO 20 holder that I'm using that has the flats so that I can make sure that it fits in here without any problems. And let me hide that so you can see. One of the things that I did is to put these little mouse bites, I guess they're called, into the corners since I can't get sharp corners. So as I say, this is a pretty straightforward part. If we look for the machining on it, it's also fairly straightforward. What I do is just some spot drills, drill through with a drill for these two corners. I want to drill them, but while all the material is there, so that the drill will go straight and not whinge to the sides. Adaptive to clear out most of the material. And I set the XYZ coordinates to the bottom right, back, right here. And that's because this thickness here is important because it's based on the flat. This distance here is not as important, so I'm basically ensuring that the important distance is going to be the correct thickness. Then a contour for the walls there, another contour for these walls, and then making sure that I deck off the bottom here so it's the correct distance. And then I have these screw holes. What I decide to do is just spot them on the CNC. And then I'm going to use the drill press to drill them and then tap them. And the reason I'm going to do it that way is because it's probably faster than loading a new drill into the tool changer, setting the offset, etc. So, I mean, it's pretty fast to do it in a drill press, and I only need to do this once, so that's how I'm going to do it for this time. First thing I did is I cut a piece of 2-inch wide by 1/2-inch thick aluminum into two pieces, one 2 inches long and the other 5 inches long. These dimensions are not precise, but I do want to clean up the edges. This one I can clean up the edges in the mill. There is a little bit of a burr on the edge here, but I don't have to worry about that right now because my vise is only 4 inches wide, so these will both stick out the side of the vise. For this piece, on the other hand, I do need to worry about this burr that I can feel. So I just want to take a deburring tool, and it doesn't take much effort to just do one pass like that, and then the burr is gone. And what I usually do is one pass this direction, and then I flip it 180 degrees and do a pass that direction, and now the burr is completely gone. So I'll do that on both sides, and then put this in the mill to clean up the ends so that it's nice and square and looks nice. Okay, now that I have it in there, I'm going to change to tool number 1, which is my 3/8 inch end mill. So a hand jog, tool 1, and then ATC reverse. And then I'll just use the hand jog to get it close. Okay, so what I want to do is get the Z so that I'm using all of the flutes, and then I'm going to get a little fairly close this way. What I'm going to do now is turn on the spindle so it's at 5,000 RPM, going clockwise, and then I'm going to move it until it, let me bring the Y back a little bit. I'm going to move it until it just starts to make chips. Right there, and then turn on the coolant, bring the Y back, and then I'm going to move it over 10,000. So it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 clicks on the jog wheel. Now I can use the jog wheel to move it forward, and that should clean up the edge all the way. So I can stop the spindle, stop the coolant, and then have a look in here. And I can just feel that it's been cleaned up all the way. So now what I want to do is move this to the other side. Okay. So that looks really good, but what I'm going to do is pull it out again and just make sure that I deburr the edges. Okay, make sure it's seated well. And I'm going to move the vise so it's closer to me. And that means it's also going to be easier to get the dead blow hammer in there. Make sure the parallels are tight. Give one last tightening on the, okay. I didn't have the jaws tight before I used the dead blow. So that looks good. Now I just need to pick up the coordinates. And for this one I'm going to be using the XY0 here, and then 0 off here, so that the thickness that's remaining is the correct thickness. This is the surface that I'm going to use as reference on the Haas. The tool offsets are always based on a known location on the machine or on the part, but I have all of the tools set to this location on the bed. So I just wanted to clean it off before I switch to the Heimer. And so now I'll go ahead and switch to the Heimer. I'll do 2 release. Okay, and I'm going to start on the offset page by getting the right side. And then I'm switching from 10 thousandths per step to 1 thousandths per step. And now I'm going to come in here and pick up the right side. And this doesn't have to be within tenths, but I always like to follow the same practice. So I'll go back to G54X, press part 0 set, and now I'm going to do the back. So I'm trying to get as close as I can to the jaws without touching them. And then I'm going to move the Z down. So now I'm picking up the parallel. And I was going at 1 thousandths of an inch, and now I'm going 1/10 thousandths of an inch at a time. And I want to get that just right. Now that I have that just right, I want to take a look at this number here, which is the offset that I want to put into G54Z. So I'll type in 3.4906, validate that this is the same thing, 3.4906, press F1, and it should appear there. It's saying it's greater than the acceptable range. Yeah, that's fine, so I'll just press OK, and now it says 3.4906. So now I can load the program after taking the Heimer out. So the first thing I'm going to do is change the offset to 0.1 and then press Z+, and that will raise the Heimer out of the way. And then I can press tool release and put my Heimer away, put the 3/8 inch end mill back in. And then I can load the program. So I'll say list programs. I want to go to the USB drive, and then I've got my ISO fixture here, and I want to select that one. So select program. Now I need to close the door and start running the program. So I lowered the Z just so that I could center up the camera. So I'll put it back to that way, go back to memory. Now I'm ready to run. I want to set rapids to 5%. I'll go ahead and set cycle start. And you can see I've got my fingers on here. And I'm all set to press feed hold, but it's looking good. I haven't changed any of the tools, but still I want to keep my finger on feed hold. Okay, that wasn't quite what I expected, but so I had the wrong tool in the program, which means I used an end mill to cut the mouse bites, but it should be okay. Okay, let's have a look. So fits perfectly. And actually it'll fit either way, I believe. Yeah, so it's designed to fit this way. And that's going to work. So even though I ended up using a 1/4 inch end mill, I think it was, to plunge through this rather than the drill that I intended to, it still should work just fine. So now I'm going to put it back in and spot the 3 holes. Okay, now for this one I need to pick up the left back top. So I'll go ahead and do that off camera, and then I'll come in and we'll just spot the holes. Okay, here we go. Okay, I hit the wrong button. I thought I was pressing stop, but I pressed cycle start, so that's not good. Okay, let's see what's going on. This is the first cam operation, and you can see that it's plunging the way that I expected. But it was plunging too early. So I was assuming this was 5 inches, and as you can see, it's actually 4 inches. So the problem is that I thought I had the stock far enough out, but I didn't have it far enough out because it was supposed to be 4 inches rather than 5 inches. So what I'm going to do is just change it in CAD so that it is, let's see, probably this one here. So now it should be 5 inches. And I'll go back to the cam, regenerate. And then repost that, and I'll give that a try. So I drilled the holes, and you can see I drilled one a little bit deeper than I probably should have, but should still be fine. I can actually check it quickly, and yeah, it's fine. And that's because the screws that I had were longer than I needed, but these were the shortest 1024 screws that I had. Then I tapped the holes with 1024 tap. I also drilled out these holes to be a loose fit, and then just did a quick chamfer on the back. So at this point, it means I can assemble this and then give it a try. So I have it set up for 3 of these 1024 screws, and I've certainly made my share of mistakes on this project, but it should get the job done, and if it really bugs me, I can just make another one because it didn't take very long to make this. So there it is, all finished. You can see this is where I accidentally ran into the vice jaw because I had the wrong length material. This hole here, that's from something else where I was using this piece before. So now let me get this mounted to the table and give it a try. All right, I have this clamped down on the table, And I'm going to put this in here. You can see it fits very nicely. And then I have this, let's see if this fits in the picture. Yeah, it does. So what I'm going to do is I'm going to change this to, reduce this to the lowest value, which is 7.5 foot-pounds. And then I'm going to put this on here and see. Okay, so what this tells me is that I have less than that torque. I mean more than that torque on it. So let me increase this a little bit. I'm going to increase it to 10 foot-pounds. Okay, so I actually had quite a bit of force on it before, just doing it by hand. So I'll go to 12.5. Let's see where we stand with that. Okay, I felt like it moved just a little bit, so that means I'm probably at 12.5. So I'm going to take it up to what it should be, which is 22. And what will be interesting is to see how much it moves in here as I... Okay, so I'm about to start applying pressure, so let's have a look. So that was a noticeable amount of tightening, but man, this is so much easier than the way I was doing it before. So I should have made one of these a long time ago. I hope you enjoyed the episode. One thing I took away from this is to slow down. If I'm feeling like I am trying to get something done quickly, that's when I need to slow down the most and stop and think, validate everything, and make sure that the tools are correct in my cam operations. In this case, I pulled in an 11/64, I think it was, drill, but it didn't have a number in cam for the tool changer. So it just set it to tool 2, which happened to be a 1/4 inch end mill. And so therefore it wasn't using the correct tool. And then of course there was using the incorrect stock length and not validating that. You get the idea. So even with those issues, I'm still happy with the results. Hopefully the errors are not something I'm going to notice. If I do notice it, it's easy enough to slow down and make one taking a little bit more time. That's also easier with not making a YouTube video, because I can put all of my focus on the project and not think about camera angles and what I'm going to record and what I'm going to say. Anyway, as I say, I hope you enjoyed this episode. Please give me a thumbs up, subscribe, comment below, and I'll see you next time.